First, I wanted to thank Hilary for inviting me to speak today. Also thank all of you for coming tonight, and thanks to Eventbrite for hosting all of us. Just jumping right in, just very briefly about me. I've been working with Django since 2007, been a core contributor since 2011, and I occasionally tweet at this handle if you're ever interested. As David said, I work at Nurun. We are a digital agency based here in San Francisco and have offices in various parts of the world. So I encourage you to check out our website, see what we were up to. But what you came today for is about this talk, and what it's about, as you probably guess, it's about Django and React. And this talk does assume that you know a little bit about both, but I'm still going to cover some of the basic principles, in particular about Flux and React, and then I'll show some examples of how Django and React can work together. So first about Flux. Flux is the name of an architecture whose core principle is about a unidirectional data flow. Now, that as a core principle is nothing totally novel or groundbreaking. This has been used in various domains before, like video games. You can even argue that the web is most of the web is based on this on the same data flow. If you consider the traditional websites that are built with HTTP request, server-side rendering, and response cycle. But it is fairly new in the world of rich web client, and it's been made popular recently with the advent of Facebook's React library. So let's take a look at how this all works. Typically, things start with an action. An action is just an event that's being triggered, and that may be done by a user clicking on something on the interface, or it could also be at a regular interval. It might be a clock ticking. So when such an action is triggered, that is called by a dispatcher, whose role is basically just to potentially fetch some new data and then feed the data to stores. Stores are basically responsible for holding the state of your application client side. And then whenever something happens, whenever new data is fed to the stores or any data changes, that data is automatically pushed to views. And then each view is responsible for rendering itself and then passing down data potentially to its child views or subviews, which would then render themselves. Now, what's really important is that whenever something happens, so say, for example, one of the subviews is a button on the interface, what is going to happen is that whenever that event occurs, there's going to be a new action that's going to be triggered, and then that action will be called by the dispatcher again and will affect potentially the state of your application. And then the data will be passed down again to the stores, and the entire view system is going to be re-rendered. So that's a core principle. React itself is all about the view system. That's all it does. It focuses on one thing, which is rendering stuff. And everything that sits outside of React that constitutes the rest of the Flux architecture. There are lots of implementations out there. You might have heard about Flumux, Fluxor, Redux, Marty. Personally, I've been using Reflux for the most part. It's the one I find is one of the simplest ones, and it's been working for me. But really, there are no clear winners at this point. And I encourage you to just check them all out, because it really comes down to personal preference at this point and to the nature of your application. So let's take a look at some of the advantages of Flux. The main one, I think, is that it frees you from having to think about where data comes from, what changed it, or why it changed. When, if you remember the diagram that I just showed, whenever something happens, you always go through the same cycles. You always render things the same way the first time as you do whenever anything changes. So, and that in itself is very liberating. So some of the benefits of this approach is that it drastically reduces the cognitive load, so you don't have to remember so much about your application, about how the pieces affect each other. You can really focus on one piece at a time and focus on how one particular piece is going to behave and render. And that also makes for a simple code base. Because you don't have to worry about how things affect each other, then that eliminates a whole class of potential bugs that typically come with how things mutate within your UI. And then it makes for a consistent, predictable behavior, because again, you only have to focus about one thing at a time. And that just does a lot to provide confidence into your own application. And then some advantages of React itself is that it abstracts the DOM with components. So you can think of your application as modules and submodules, and that makes it a lot easier to divide the work within a team, for example. And it also makes it allows you to focus on one piece at a time. And it also handles all of the DOM mutation automatically. DOM mutation is something that is inherently hard and tedious to do, especially in an efficient way. So React, for the most part, handles that automatically for you. So that's a lot of work that you don't have to worry about. And it's also agnostic about the rest of the stack. Again, it focuses on the view system. It can work with any other sort of JavaScript libraries out there, any backend, it doesn't really matter. As long as you feed it data, no matter where it came from, it's going to render it. And then we talked about Flux earlier, and that sounds like a great idea, but until now, it wasn't really viable in the browser because this constant rendering would cause a lot of flickering in interface. But because React comes with some really clever and smart ways and efficient ways of rendering the page, and all of those components, it does make Flux as an architecture totally viable now in the browser. So now I'm going to show you a quick demo to illustrate some of those principles. It's a very simple app. It's basically a list of photos. You can click on those photos to favorite them, so you can toggle your favorites, and then your favorites will appear in the right corner. And then you may also filter your photos depending on whether it's a color photo or a black and white, depending on how they've been marked. But first, I wanted to show how React and Django work together. First, so Django, for the most part, is going to focus on providing an API to have access and to manipulate the data server side. And React is going to focus on rendering the UI client side and also to handle all of the user interactions. And this is how those pieces sort of fit together. So first, React is going to render the page initially. And then whenever a user will click anything, it's going to click any of the photos on the page, there is a post request that will be sent to the server via an API. And then Django will update the database, will serialize the current state of the data. So we serialize all of the current favorites and then send them back to the client. And then from then on, React is going to use that data to re-render the page. And we're going to follow, again, this unidirectional flow of data. Now, you might be wondering, OK, so how does React have access to the initial data? How is it going to hydrate its stores to load the initial data to do the first rendering? There are several methods you can use. I'm going to present two of them. The first one is one that you might think of as conventional. So first, you're going to receive your empty document, and then you're going to do another AJAX request to the API just to get the data. And then React is going to render the data, the UI. Another method, which you might think is a bit less conventional, is that on the very first request, Django is going to serialize that data and stick it into a JavaScript variable and output it into the initial HTML payload. That's how Instagram does it. That's just one way to save an extra call to the server, an extra round trip just to collect the data. So now let's take a look at a live demo. Pretty simple. Again, so you see all those photos, and you can click on them. When you click, they then appear here in the corner. You can also delete favorites by just clicking on them. Simple stuff. You can also filter photos on whether they're color or black and white. You can also re-render the way the photos are presented, either as thumbnails or a list view. Not sure why it's slow today, but anyways. So also want to show you every time that you click on a photo, there is, if you can see at the bottom here, well, I'm actually sitting on it, but so there's a post request sent to the server every time. All right, so that's a quick demo. Let's take a look at how the backend works. So in the backend, we have a very simple app with some simple models. Is that big enough? Yeah, cool. Simple two models, one that will host, that will hold all of the photos with the URL and a flag, a Boolean flag that says if it's a color or black and white. And then a favorite, which is basically a list of pointers to the photos that have been favorited. And then we have an API that is powered by Django REST framework in this case, and it's all pretty standard stuff. The only piece of customization I've done here is for the favorites, create and destroy methods, which is basically when we create a favorite or delete a favorite. So for those two API calls, I will first do the initial reason. So in this case, when I create, I will create the object in the database. But then I will also package up all of the current favorites and so that I can serialize them and send them back to the client. This is just an optional optimization, and I will talk about it and why I do that here. Okay, so here I'm going to show first the first method, the conventional method for the initial hydration, and that's when we do a separate AJAX call here that you can see. I'm making two AJAX calls to fetch the photos and the favorites, and you can see here there's also a loader that is displayed. So let's take a look at how that's done in the front end now. So first of all, this is the very simple view that is rendered by Django. It's just basically empty. There's nothing in there. We have, and I can show you the source here. There's basically nothing here. That's the initial HTML payload that comes back from the server. The advantage is that it's really fast. There's nothing in there. So at least we get to see at this point the title of the page. So here I've made this function that's going to get called. So we are going to first render the controller, which the main controller, which in this case, the very first time, since the store has not been hydrated, is going to render just this progress bar here, which is what you see here at the beginning. And then in the meantime, we also launch this this method here, fetch data, which is going to fetch the data via AJAX, and that is pretty simple. Also, if I look at that method, all it does here is to do a couple calls to the server, and once we have the data, it will then hydrate the store. And at that point, once we hydrate the store, the UI is automatically going to be rendered because the views are listening for any changes that would happen in the store. So this is what would happen at this point. The render method would be called again automatically once the data has been received. But this time, since the store has been hydrated and we do have data, we are then going to render that custom component, the album component that I've created, and we will pass it down the data that we have. Now let's take a look at this component. Again, pretty simple stuff. Here, by the way, you might see that I'm using, so for example, the progress bar, and here I use a few components like grid, row, call. Those are provided by React Bootstrap. It's just a React implementation of Bootstrap. That was just to put up a demo together quickly. But just the idea is that you can build your own component in the same way. So then you can build your application like Legos, basically. So here I've created my own component. That's the photo panel and the favorite panel. The photo panel is everything here on the left side that contains the control bar and all the photos, and that's a favorite panel here on the side. So the photo panel, I pass it the photos because it needs to render the photos and also the favorites so that it knows which ones to highlight, whereas the favorite panel only needs to know about the favorites. Let's take a look at the photo panel now. So here, the very first thing we do when that render method gets called, again, automatically, as soon as we pass the data, We first need to filter the photo based on the current photo type that's been selected in the UI, whether it's a color or black and white. So that's why I have this simple function here that's going to filter the set of photos and return just the ones that need to be rendered. So once we have these filtered photos, we then pass it down to this function here. That's another function I created, I wrote here. And here there are going to be two paths. It's going to check what is the current layout that is selected. So in this case, it's the thumbnails, based on those two buttons here between list and thumbnails. So based on that, it's going to render our current photo as, so here, a thumbnail, or as a list item. And here again, it's some simple code that's going to use some of that React Bootstrap, some of those components, and I would just pass in the value, in this case, the photo URL. What we also pass here is the action that we want to be triggered whenever something is clicked. And in both cases, it's the same action. We want to toggle on and off our favorites. So here we pass the same action, whether we're displaying it as a thumbnail or as a list item. It's the same stuff. So here again, you can see that the same events are happening regardless of which view is displayed. So here what I want you to showcase is that at no point here in my code I say, oh, okay, so remove this stuff and then put this stuff in, or swap this stuff out. All of those mutations are handled by React automatically. All you have to do is to change the data, and then your entire thing is going to be rendered. So you only need to describe how things need to be rendered given a state. Okay, so that's sort of how the rendering happens. So something I also wanted to show is the other potentially less conventional way of initially hydrating your stores. So I have a separate version of that I've built. So at a different URL. And here it's exactly the same stuff. The only thing that differs is what happens in the very first place. If you can see here, the data has been serialized and stuck into the HTML as a JavaScript variable. And that makes it super easy then to hydrate our stores. So this is the method that will get called. So here we just need to look up the values inside that variable, and then we hydrate the stores. And from then on, everything else is going to be rendering exactly the same way as I described earlier. Now, there are pros and cons between the two versions. This version, the pre-serialized way, is that the data is going to come with a very initial payload, so you're all ready to render your page. But if you have a gigantic amount of data to display, then that might not be viable because the very first load is going to be pretty slow. So in that case, you might want to resort to an Ajax call instead. And on the server side, to do that is also pretty simple. So this is the version that I'm using here. That's the view. What it's going to do is going to use the exact same serializers that I'm using in the API. And then it's going to serialize them as JSON and pass them onto the template. And here we'll basically just stick our data in there. So if you want to see, that's how Instagram does it, if you want to view the source. OK, there is something else I wanted to talk about. And that is server-side rendering. So they are...
How about infinite scrolling sort of thing if you want to implement that?
Sorry, say again?
Infinite scrolling sort of thing, how would you go about implementing that?
Oh, infinite scrolling. Oh, there are different ways of doing that, but the question was, how do you go about doing infinite scrolling? So it depends. So if you do not have the data already, you want first make an exact scroll to get the second page, and then you would basically rehydrate your store with the data that you get, and then everything again is going to be rendered automatically. So all of the new items are going to be stuck right underneath automatically. So then if you want to go with some smooth animations, there's a few tricks you can do, but that's more or less how it works. You basically just need to feed new data to your store, and then everything's just going to get rendered. So the second page, and so on. So about server-side rendering. So there are several advantages of doing that. First one is that it's SEO friendly. If you have all of your content on your page that is already rendered as HTML as it comes in the very first payload, that's going to make it a lot easier for search engines to index your page. It's also less resource intensive for the client, and that really matters if most of your audience is mobile-based, because mobile devices don't have as much CPU power. So if you can save those devices the initial rendering, then that's best, because then won't have to wait an extra second or two for your page to be rendered. And it also means that the first page is already consumable. You can already start reading without waiting any sort of rendering. And what React allows is to use the exact same code base on the server and as you would on the client. That is called universal JavaScript, also sometimes referred to as isomorphic JavaScript. And so that's something that's really cool. Before that, if you wanted to achieve server-side rendering as well as client-side rendering, you'd have to consider doing, so if you use Django, you have to pre-render everything using Django templates, and then create a set of templates on the client that would be rendered with JavaScript using, for example, Mustache or Handlebar, and you'd be maintaining those two sets of templates, which could become a headache if you had to update those templates all the time. So the cool thing here is that you just write your React components once, and you're going to be using the same on both sides. And it is actually pretty easy to implement if you use the right tools. I recommend using Python React, which is a pretty small and cool app that allows to do server-side rendering with Python, and it also comes with some Django support. And you're also going to need a very small Django HTTP server running in your machine. So here's how it works. So very first time the user visits your site, types in the URL. So there's an initial request sent to the server, a GET request. Django is going to then fetch data from the database, serialize it as JSON, and pass it over to a separate Node JavaScript server, Node server, whose sole purpose is going to be to accept this data, use your React component to render whatever it is there is to render, and then return some HTML. And then Django can do some final assembly and then send that HTML back to the client. And then after that, once you have your page pre-rendered, every subsequent re-rendering that happens based on user actions is all going to be done in the client, just like I showed you earlier. And the cool thing here is that you can use the exact same JavaScript code. So I can show you some code. I have it on the slides, but it'll be easier to actually show you here in the IDE. So let's take a look at the demo first. So I have a separate version here of this demo. And again, exactly the same stuff, exactly the same code as I was showing earlier. The only difference is that initially we have all of the HTML that has already been rendered. So let's see how that's done. So here we have a separate view. This is the view that gets called at this URL. Here, same thing again. We use the same Django REST framework serializer to serialize things exactly the same way as our API does it. And then we use this function called render component. That is the function that is provided by Python React. So what this is going to do, what you need to do is to specify a component, and that is the component that I showed earlier, the same one. And then what it's going to do behind the scene is that it's going to package this all up, send an HTTP request to your Node server that will accept that data ready to render it. The Node server itself is also pretty simple. So here I've implemented it using Express. And really, it comes down to a dozen line of code. It's all super straightforward. All it does is that it accepts any request at a given port. And then we'll take those specifications, so which component and what data. And then it will use this React render function to basically render this component exactly the same way as I showed you earlier, that exactly the same stuff that's happened in the browser earlier. And then we get some HTML, and then we send it back to Django. So this way. So we send that HTML back to Django. So then once we have that HTML here, we're then ready to pass it down to our template. And then all we have to do here is to basically stick that template into our that HTML into our template. And that's how you basically get this. And then React is basically ready to take it from there, and then everything is going to be rendered exactly the same, using the exact same code basically. And that is effectively it for this talk. DjangoCon, I'll have a little bit more time, so there are a couple more topics that I'm planning to talk about, and that's about how do you manage asset pipelines, and also a couple tricks on what you can do with Django to test your React components. But for now, that's about it. Thanks for coming. I hope you enjoyed it. And if you have any suggestion on how I can improve this talk, then please come and see me after. Thank you. And I'm happy to take any questions that you may have also.
Code you were showing somewhere on GitHub available, or?
It's not there yet, but I'll post it on GitHub, yes. Maybe I can, once it's on GitHub, I can send you the URL and to post it on the event page. Yeah. And I'll tweet it if you follow me.
Thank you.
Yeah.
Of all of those options that you just covered, would you say server-side rendering is the best choice?
It really depends. There's no one-size-fits-all. It really depends on the nature of your application. If you have a content-heavy site that can be cached, then that's great, because you won't have to do all those round trips with that node server, because there is a cost in doing that. If you can cache that, then it's a huge win. And it really depends on how much data is going back and forth between the client and the server. It depends on your audience. If your audience, is using some really powerful browsers, some modern browsers on some modern machines, then there's no point in doing server-side rendering, because it's all going to be pretty fast. If most of your audience is mobile-based, again, if you can save them a little bit of effort in the beginning to render, then that's something to be considered. So this is why I wanted to present all those options. I'm not saying you should be using this always or this always. Really depends on, they all have pros and cons, basically.
Yeah. How do you get React on the front end to respond to the server-side rendered HTML?
So if it's been pre-rendered, how do you get React to deal with it?
Yeah, like the components and the data that's attached to it.
So React
continuous state.
So React will just accept it as if it had rendered it himself, and in fact, it has. It just, it's its clone on the server that's rendered it. As you might know, React, to make all of that constant rendering efficient, what it does is it first renders everything into memory, and then it compares that, so that it's called the virtual DOM. It compares the virtual DOM to the real DOM, and then it will try and find the differences, and then apply those differences. So if your page comes pre-rendered, and the data is consistent with the data that React has in the browser is consistent with what's been used to render that page, it will render the page in memory. It will compare it with that pre-rendered stuff, and we say, hey, it's the same thing. Okay, done. My job is done. I bail out, basically. Sort of how it works.
what is the reason of having another layer of Node.js app to do the server-side rendering rather than just do the server-side rendering in Django?
Oh, so it's because React is JavaScript, and you need a JavaScript VM to render that, to execute that code.
Isn't that what Python React is doing, the module?
No, so Python React is just that, it's really just that function that I was showing, that convenient function. So you could use, for example, requests, and then package this all up, send that to that node server React. That node server. Anyway, so that is basically what comes from Python React. It's just a convenient function. You give it some data. You specify which component you want to render, and it also comes with some nifty Django integration. So, for example, it's going to look into your static folder to find your components. So, it does a couple things like that. It will also render. So, if you pass it some models, it will use the Django model serializer also to serialize it to JSON. So it just does those little things that that you don't have to do yourself. But at the end of the day, it's still going to emit that HTTP request. Now, there's something cool about it is that you could also host that node server somewhere else. So you could, it's one cool way of distributing your node servers responsible for rendering that stuff, and then your Django server might be running somewhere else. So it's also a neat way of thinking about the architecture of your entire backend.
All right, thanks.
Mm-hmm.
So you mentioned how React automatically reacts to sort of client-side actions. Mm-hmm. Can you also set it up to react to sort of server-side actions and more like a comet-style polling kind of situation where it automatically re-renders based on new things that are happening server-side?
Absolutely, yeah. Again, React is never looking up. It never looks where the data comes from. All it knows is that some data just suddenly appeared. It doesn't matter what brought the data over. So you may use it in using WebSocket, but with the server pushing data constantly to the client. All you need to do is a little bridge that's going to be reading that data and then passing it over to React. And then you'd be using exactly the 100% of that code I showed you could be used in a context of a real-time WebSocket scenario.
All right, let's hear it for Julien.
Okay, thank you.